week so far. We didn't meet last week because I was into doing corporate stuff, and then now we're gonna come back to do what we're supposed to be doing. And thank you for your understanding for last week. And then some of you, I was able to speak to some of you on Tuesday. Okay, so hopefully everything goes well with you right now. Is there any specific question that something that I don't know if I messed up something, anything? I don't think I have an exam yet, but it's gonna be soon. See you again. Yeah, so our next test will be we're gonna have spring break and on the 13th. I think one time I messed it up, but it's gonna be on the 13th. I think is the right date. And then after that, you're gonna have your second test. Okay, that's what we're gonna be doing. Okay, so this is clear. So if I will be wasting too much of your time, I'm gonna be good afternoon, everyone else. I'm gonna be talking about what the subject for today. Okay, so far we spoke about probabilities. After talking about probabilities, we explained the properties. So probably cannot be more than 1, cannot be less than 0. And then probably something that's impossible would be 0, that is certain to happen would be 1, and so on. We also talk about the additional rule for probabilities. Whenever you have the P of A or B, it's going to be the P of A plus P of B and P of A minus N B, something like that. And then now we need to introduce another concept of that probability concept, but it's going to be conditional probability. So let me share my screen. Before I do so, give me one more second before I share my screen. Start the slide. So that. Okay. One second, please. So let me share the screen. Oopsie. All right. This is what we have. We're going to be talking about conditional probability. Let me just go up a little bit higher. Okay. We talked about that in last week already, the week before. Yeah, conditional probability. So conditional probability is probability of an event occurring given some additional knowledge. I mean, the conditional probability, in fact, it means that is dependent on something else. Okay, that's mean one thing is the cause of the other one. Okay, one thing must happen first, then the other one will happen after that. In fact, that's why it's about the conditional probability. Okay, so let me just give me one more moment. Let's see. Okay, I couldn't see the screen. Okay, then yes. So what I was saying is that something that must happen first is that there's a condition that before something else happen. Okay, that's mean the outcome of and some event is dependent on the outcome of the other event. We do have notice here for me. So this one say, find the probability that a person will vote for a tax cut given that the person is a Republican. So here the condition is based on being a Republican. Then what if you're a Republican, how do you file your tax? That'll be the concept about it. As you can see, there's a there's an ID behind it. Okay, that's a conditional probability. Okay, that's you can, instead of saying given that, you can also say knowing that. Okay, either you say given that, you can say knowing that the person is a Republican. So we want to know the conduct of a Republican when he filing for a tax cut. Okay. And then another one. This one say find the probability that a student who is a psychology major is also a vegetarian. Okay. So this is a couple examples that we can understand the idea. I'm going to talk about numbers now. Here we have a table. Okay, and that table you're talking about male and female while taking cars, bike, walk, or the bus at home. I mean, or the bus to go to work probably. Okay, so in that table we have about 165 people are taking cars, 21 are taking bike, etc. And to give you a total of 278 people that you are doing the interview. You are, but I have the time in my mouth and my mind is coming up. These are the people you are testing. You're asking the questions. So you test, you survey, that's the term, you survey about 278 people, okay? And this is what happened. Now, let me go back quickly up to the previous statement. As you can see, this one say find the probability that the person will vote for a tax cut given that the person is a Republican. So this is how we express a probability conditional probability. We use the symbol P, and then something like this. You're gonna put A, and then you put a slash, and then you're gonna B, something like that. This is how we express it. This one stands for probability of A given B. Okay, that's how you read it. Probability of A given B. As you can see, there's a slash. It's not a division sign. It's just a slash to stand for given. It means that also the probability of A, knowing that B already happened. Okay, you can say probability of A knowing that B happened first. We can say happened first or already happened. Okay, it happens, the event B happens first or it already happened. Okay, so that's mean B come first. So that's the symbol we use for it. Okay, and the example here we say probably that a person will vote for a tax cut. Suppose I say they use the symbol TC for tax cut. Okay, and then they use the symbol R for Republican. So the way I'm gonna write this one, I can say P of, okay, TC, knowing that the person is a Republican. I can use symbols to make my written shorter, or I can say probability of tax cut given that we are a Republican. Then I'm going to find, I will teach you, soon I'm going to tell you how to work this kind of problem. Republican. Okay, so that's the idea behind that. This is how you express the symbol. Now, this is an example here. This one saying, for example, what's the probability of boss given female? Okay, this is what it means. It means that the probability of writing the boss, knowing that the person is a female, or the probability of writing the boss, given that the person is a female. Now, the condition here is based on the female. Okay, it's not the same thing as this one. Suppose I put, suppose I put this one right here, P of female. Okay, I'll talk about this one later. It's too early for that one now. So I just want to explain to you that whenever you say P of birth / female, it means that probability of writing the boss, given that the person is a female. Okay, so how does it go? A quick idea. So first of all, I haven't talked about the formula. I'll be talking about the formula soon, but let me just give you the answer for that. So this one says it's going to be 32 out of 154. Okay, so this is the probability that you're a female, then you add the boss. Okay, so it's right here, 32 out of 154. Okay, so this is whenever I given the table. All right, so what I wanted to do, for example, probability of work, given that you're male. Okay, the concept will be the same thing. You will say this is equal to work will be 12 out of 37, right? Out of 37. Okay, so that's the concept behind that. But I will be talking about this, the regular formula for it, because not all the time you can have a nice table like this to help you out. Okay, so boss and female, it be 30. If you say you are female and you have the boss, is 32 out of 278. So this is two different concepts. They're not the same concept. When I say boss given female, they also say boss and female. So these are not the same concept. If you say boss and female, that means it's going to be 32 out of 278. But if you say boss given that is a female, is a conditional, that'll be 32 out of 154. That's not the same concept. Okay? Any question about that? We previously talked about and before. If I say, look at here, probability of you're a female and you have the boss, then it's gonna be 32. The number 32 gonna be that number 32 out of that number 78. Okay, because it's the people that are female and you have the boss. But the one on top, there's a conditional on it. It's a conditional. Okay, it's a little bit different. Okay, so it's not the same thing. So you can just say, suppose I say probability, suppose I say probability of the person who work, and you're male. So that answer will be different. I would say that's going to be 32 out of 278. Okay, then you know, not 32, my mistake, is 12. Why did I think I do 32? That's 12 out of 78, 278, that's 12. So, but remember that I didn't use my calculator, but you just have to simplify it. Okay, make it simpler. So it'll be 12 out of 278. Okay, these are the number of people who are male and work. You work and work to go to work, for example. Okay. I'll be talking about the formula soon, but before we do, just a quick idea. This one say let A be the event that a person is left-handed, and B the event that the person is over 30 years old. So they say what symbolically, the probability that a left-handed person will be over 30. Okay, so the left-handed person will be over 30. So this one say let A be the event that the person is left-handed. Come on, somebody's coming. Give me a moment, please. That be the event that the person is left-handed, and the event that the person is over 30 years old. What simply say the probability that a left-handed person will be over 30. So notice that the way it is written, it say a left-handed person will be over 30. It doesn't say there's a condition, but the condition here is you have to be left-handed first. Then we're going to be over 30. Okay, left-handed, then you have to be over 30. The condition here, the condition here, you have to be left-handed. Okay, so because it say you are left-handed and you be over 30. Another way to say that, you can say probability that you over 30, given that you are left-handed. You can say, so A is the event that you are left-handed, B is the event that you're over 30. So another way it's written can be confusing. I mean, it looks simple, but this is just a conditional. Okay, you say you have to be left-handed, that's a condition, then you be going from over 30. So the way we're gonna say this one will be left-handed will be is A, okay, and then over 30 will be B. Okay, so the condition is being left-handed. So we're gonna say this gonna be probability that you are left-handed. I'm sorry. Probability that you'll be over 30 because the condition is on left-handed. Probability will be over 30. Just fix it. Probability that you over 30. Remember, the condition is you have to be left-handed. Then to be over 30. So you look for people that are left-handed first and say, which one of you are over 30? That's the idea behind it. So you'll be over 30, knowing that you are left-handed. Okay, so you're gonna say P of B given A in that case. All right, P of B given A. Now, this one say a person is lefty who is over 30. Okay, a person is lefty. You say the final part of a person is lefty who is over 30. Okay, so this one also, the term, it can be tricky. Okay, so this one say a person is lefty who is over 30. So you want that person that is lefty to be over 30. Okay, but look at the way the term is done for the first one. This one say a left-handed person will be over 30. This one say a person is lefty. And I think the word who is kind of crazy, but I would say a person is lefty who is over 30. That means in this case, the person is both lefty and also over 30. I don't know if you guys see that. It's a person is lefty, and that same person is also over 30. So in that case, a lefty will be A right here, and then B will be over 30. In that case, you're gonna say probability of A and B. Okay, so what I'm trying to tell you that sometimes you have to pay attention to the term. And then when you do the review for the exam, it might help a little bit. Okay, let me see. I think somebody tried to get in now. Give me one moment. Just make sure. Okay, so the person is, you said the person is lefty who is over 30. Sometimes I put myself in the exam, it might be a little bit more specific. I would probably say a person is lefty and over 30. So just to make it a little bit more challenging, we just put a person is lefty who is over 30. There's no condition here. Here the person is both lefty and over 30. Okay, that's what it means here. Okay, so, and then one say, a person over 30 years old who is a person over 30 years old is righty. So the person who is over 30 years old but is a right-handed. Okay. Again, in this case, the probability trying to do here is to find the probability that the person is righty. But in that case, the condition will be is over 30. Okay. So here, this is B. Okay. And over there, righty, we're talking about left-handed person. In that case, you're gonna have to put A with the complement. We talked about A complement before. Whenever I'm talking the property of probabilities, this is a probability for something not to happen. Okay. But in this case, you can find the person is a person over 30 years old is righty. The probability that that person is over 30 years old is righty. So the concept might be complicated sometimes. But in that case, this is what you say. It's going to be the probability that the person is righty, knowing that it is over 30. Okay? Is righty, knowing that it is over 30. All right? So I'll put the notes for you so you can understand after that. Okay? Does anybody have any question for me before I continue? Any questions? Okay, so now I'm going to talk about the formula, the exact formula for it. Earlier, we did a couple of examples. It was visual, but now let's talk about the formula for that. This is a formula.
Sorry, I do have a quick question.
Yes.
Can you go back and again, what is the C on there? On
Oh,
A
it means the complement.
complement.
The complement. Let me remind you where we did it before. Let me just go back quickly to probabilities. One moment. When you talk about probability, where is it? I like to go back and show what I did, what we did. This is the definition right here. I think that was there. You see that? Whenever you talk about probability of rain, so A will be rain, right? AC will be no rain. This is called the complement of it. Do you remember when we did that? And that's a lot of information. Sometimes it might be hard.
All right, I got it. Thank you.
Or some books use different pattern. Some books use this one. This one read as A prime. Okay. A prime, like Optimus Prime. And this one is what as A bar. They all mean the same thing. This one is you can just say complement of A. How do you put it there? It's complement of A. Or A complement. Okay. That's how we did it. So let me go back to the notes. And then we all the way to where? To this guy right here. So that's the definition. Okay, so that was the last thing we just did. Right here, we did that, okay? Now this one this is the formula. It means that this is, whenever you talk about in the future, so this is a formula you need to write on your little notes. It's gonna be P of A given B is equal to P of A and B over P of B. The reason that you need to know the probability is simple. You're not going to have very simple examples, and then that will show you, just like we did the example earlier of the little table, showing the woman driving the bus, going in the bus, or getting their car, or the man walking to go to work. It's not going to be that simple. Sometimes it might show, I might give you just a simple paragraph, and then this is when you have to use a formula, okay? So the first thing we're going to be doing is find what A and B has in common. and then over the probability of B. All right. So this one say use this formula when explicitly given the probability of a person. If you are given the probability of a person, use this formula. Okay. So whenever you are given a table, just like we did before, you don't really need to use the table. You don't use the formula, but it's good to do it anyway. Whenever I put it on the example, I'm going to show you both ways. Okay. But well, I'm not going to do example yet. But let me see. Do I do an example now? Let me see. What are my example again? Let me just go do an example right now so we don't forget what we're talking about. Let me see where my example again. Okay, let me do an example with you using the formula. I'm gonna go all the way to here. This is a table that we have, okay? And then this is gonna be a man and a woman, okay? So some are right-handed, some are left-handed, okay? At the same time, oopsie. What are gonna be so first expand the table. So how many people are right-handed? You can see that it's about 60 people are right-handed. If you do 18 plus 42, how many people are left-handed? You're gonna be 40. How many men do we have that are participating in the survey? We saw that is about 30. How many women that are participating in the survey? Is about 70 women. Okay, now suppose I ask the first question. I say, oh, I'll just show you the answer. Probably to be a right hand. Probably to be a right hand, as you can see, that's just going to be 60 out of 100. Okay, let me just give an example. If I say probability of being a man in that case, probability of being a man, just a man, that's going to be to be a man, that'll be just going to be 30. All of the samples, 100. That's just going to give you 0.3. Okay. Now, if I put something like this, that's a probability that, okay, your man, let's put M for men, your man, given that you're right-handed. Okay. So using the formula, we're going to do 2 ways. So if I don't use the formula, probability that you're a man, okay, given that you are right-handed, if I don't use the formula, I'm going to say that it's going to be 18 out of 30. And I'm going to have to simplify it, okay? You're a man, okay, given that you are right-handed. Okay, so let's do it together. Oh, no, I need to do this one after, just in case I messed up here. Just erase that. Okay, let's do it together. So where's my pen? Yeah. Probably that you're a man, given that you are right-handed. That'll be, I think I did backwards. No. Give me 1 moment. Eraser. So we're gonna say probably that you're right-handed. That's what I mean. Probably that let's do this one. So probably that you're a man, given that you're right-handed. Okay, so that's gonna be probability that you're a man and you're right-handed. Okay, over the probability that you are right-handed. Okay, so probably being a man and right-handed is gonna be 18. Okay, that'll be 18 out of 100. That's what I did mistake earlier. And the probability that you're right-handed, that'll be 60. Okay, 60 out of 100. Just like out of here, probability of right, that'll be 60 out of 100. Now, because you got the 200 repeat itself, it can go away, and you got 18 out of 60. So right here, we have 18 out of 60. Okay, visually, if it's a probability of men, given that you're right-handed, so that'll be 18 out of 60. Okay, then you can simplify that. You know how to simplify, okay? So now, let's do one more. This one say, probably that you are right-handed, okay? Given that you're a man. This one says it's gonna be 18 out of 30, okay? Here, men is at the bottom. So you got 30 men in total, okay? Here we have the right hand is at the bottom. You have 60 right hands in total, okay? So that's a trick and effect you have to do visually, but not all the time you're gonna be given that table, okay? So here you got 18 out of 30. This is why you are right. You use your right hand, knowing that you're a man, okay? Any question? We're gonna come back to that example soon, all right? So I just want to give you an idea of how to work it out, the formula. So let me go back to my notes. Okay, we're talking about the formula right here. So you say I'll go at the same time. If you have P of A, B given A, then you're gonna have to put A at the bottom. See, this one is always at the bottom. Okay, if you have B given B, then you're gonna put B at the bottom. So they do match. Okay, this one do match. All right. And also notice that P of A and B is equal. Notice that if I do some calculation, P of A and B is also equal to P of A given B times P of B. So I do a small multiplication rule here. So you're gonna have like, if I can remind you, so P of B given A, okay, is equal to P of A and B over P of A. So what you do, P of A and this one, because I'm doing this guy. So what you do in that case, you multiply both sides by P of A. P of A, then P of A on that side, and the P of A goes away on each side. So therefore, you're gonna have P of A and B is equal to P of A times P of B given A. I know the example I'm showing what I wrote here. There's a little mistake in my notes. So this one here, yeah, when I was talking this example here is not this one here. Okay, it's on that one. So I was trying to explain you that the A is at the bottom is the same. This example here go after that. This is the next part here. Okay. In that case, you multiply both sides by P of B. P of B on each side here. Okay. Then you're going to put P of B on that side. So the P of B goes away. Then you're going to have P of A given B times P of B. All right. So they're not the same examples. This one goes with that guy only. Okay. So So what I want to show you, so look at something carefully. This one say P of A and B, and the other one say P of A and B. It might be confusing, right? And this one says P of A and B is equal to P of A given B times P of B, and the other one say P of A times P of B given A. Okay. So don't be confused if this is what it just means. It means that P of A given B is not the same as P of B given A. And it's just like that. It's not the same. Okay, so remember that P of A given B is not the same as P of B given A. And also I can show you the example we did earlier today. If I go back to it. So where's my example? Right here. As you can see here, I was in P of right. P of you are right-handed. Okay, given that you're a man, that's going to give you 0.60. Okay, or 18 out of 30. And the previous example earlier here, we see that you're a man, knowing that you're right-handed. So, and this one gives you 18 out of 60. So if I use my calculator, 18 out of 60, how much it will give me? So 18 divided by 60, that gives you 0.3. As you can see clearly, that P of M given R is not equal to P of R given M. They're not the same thing. Okay, so I can put R for right and M for men. They're not the same. So that's why I want to try to, because one of them give you 0.60, the other one give you 0.3. All right. So let me go back to my examples earlier. I was talking about right here. So they're not the same. I'll just give you an example about it. Does anybody have any question about it? Okay, now, I just want to go over an example. Let me give something in which you must use the formula. And this one, I don't give you any table. It's going to say by 2020, 2% of Americans will be senior citizens living in poverty. So sorry, 2020 already passed. And then that's just an old example, okay? Because that, as you can see, this example was created in 2014, okay? So you can change it if you want it by 2023 or 2024, okay? You can change it. Okay, by 2024, 2% of Americans will be senior citizens living in poverty. 70% of all Americans will be senior citizens in 2024. So it's 2024 right here, because we already passed those times. What percent of all senior citizens will be living in poverty? That is the first question. So what percent of all citizens will be living in poverty? So this one say, what percent of all citizens will be living in poverty? That will be the question. Notice that we can say A represent the senior citizen. B represent the living, and means living in poverty. Okay, so you want to know the percent of people living in poverty. Okay, notice that the first way say 2% of Americans will be senior citizen living in poverty. Okay, that's your B event. 17% will be senior citizen. That will be your A event. Okay, so notice that 2% of Americans will be senior citizen living in poverty. So here on the first one, it said 2% of American. Where's my cursor? When I'm trying to find my cursor, I lost it. Okay. So here we are senior citizen living in poverty. This is two things right here. You are senior citizen living in poverty. That means this is the probability that you are a senior citizen and you live in poverty. Okay, that will be 0.02. So because say 22% of Americans will be senior citizens living in poverty. Okay. Next one say 70% of all Americans will be senior citizen living in poverty. All Americans. This one is a bigger percentage. In that case, this one will be P of A. All Americans, for all Americans and living in poverty, that will be P of A. Right here, that's going to be P of A. P of A, that will be 0.17. Okay, these are all Americans, and then that will be just the 2%. That will be American and you senior citizen and poverty. Senior citizen and poverty will be 2%. You're American and living in poverty. You're American and senior citizen, that will be 17%. This is American senior citizens. Okay, 17%. That's from the data set. So this is what we got so far. Living in poverty, senior citizen living in poverty will be 2%. Okay. And then you are a senior citizen in the United States is about 17%. Okay. Now we would like to know the probability. We want to know what percent of all senior citizens will be living in poverty. So the question is kind of hard to understand if you don't take time to read it. But this is what happened. You want to know the percent of all senior citizen. Okay, you're all senior citizen who are living in poverty. Okay, I'm sorry. If you say what percent of all senior citizens will be living in poverty, here we're talking about the condition here. In that case, will be senior citizen. We want to know the percent of them who will be living in poverty. In that case, here we have senior citizen right here as you A, and this is B. So we want to know what percent of them will be living in poverty. That's been the condition in that case. The condition in that case will be just going to be on the so when I'm saying the person in that case will be just going to be on the senior citizen. So you want to know what the person of them that will be living in poverty. What we're going to say here, what is going to be P of B, the probability to live in poverty, knowing that you're a senior citizen. That's actually you should try to understand. Probability of being living in poverty, knowing that you're a senior citizen. Okay. Well, you have to understand the question. Okay, it says what percent of all senior citizens will be living in poverty. That means here the base is senior citizen. Percentage of them will be living in poverty. It then say what percent of people what percent will be living in poverty. You want to know. It doesn't want to know that person living in poverty, but you have to know this is going to be for senior citizen. The base will be senior citizen. Okay. So in that case, you can say P of B is going to be that number, 0.02 divided by 0.17. Okay, so how do you do that? It's going to be the formula again, P of B given A, that'll be P of A and B over P of A. Okay, here P of A is 17%. Okay, that is 17%. This was 0.17, and this one here is what's it again? 0.02. Okay, here we go. When you put this number together, that'll give you an answer. So that means sometimes you're gonna have to go beyond, try to see behind the curtain, understand what's going on before I can do the problem. Okay. So if you do the math, you're gonna give 12%. That's mean in 2024, about 12% of all senior citizens will be living in poverty. Okay. So that was a quick example. In that case here, it's hard to use a table. It's really hard to use a table. And then because we don't have a table here, it's best to use the formula. Okay, any questions? Somebody say, do the recent option. Oh, I didn't see the question. I'm using two screens, and then apparently I left my eyes in one screen specifically. So Kathleen, what was the question, Kathleen? You say, I don't understand when you multiply. Okay. So what about you, Savannah? You wasted your hand? You good? For some reason, I didn't pay attention. I'm using two different screens. And then sometimes I don't see people whenever they raise their hands. I'm gonna make sure I had the chat on, but I'm gonna show also the participants so I can see that. Okay, just in case. Okay, sorry about it. I was just focusing on one screen. Okay. All right, then. So let's see what I can talk about. Now, before I continue, and I want to point out something. So let's see here. This one say, I know the term say independent events, but before I talk about independent events, this is what I want to remind you. Earlier today, I did something like this. I say, for example, P of A and B is equal to P of A times P of B given A. I don't know if you guys remember when I said that earlier today. So if you don't remember, so I want to remind you, okay? So that's what we did something like this earlier. Just make it a bit nicer. P of B given A. All right, we talked about that earlier today. Whenever I did the formula and I divide both sides by P of A, something like that. That's what I did. All right. So this one is also a rule. We can use something called a multiplication rule. Multiplication rule of probabilities. Okay, it's called multiplication rule. So let me just make sure you are nicely so people can see it for the notes. Multiplication rule. Okay, so with my pen, rule like this, R-U-L-E. Okay, and then as you can see, there was a condition. The condition was based on A. All right, that's mean B will not occur if A didn't happen first. Okay, remember we said that B will not occur if A didn't happen first. That's why the P given A, B given A stand for. That means A have to happen first, or A occur first, then B gonna be happen after that. There are some cases in which it's in which B, even though B, you can say B, A can happen first, but sometimes there's one case in which both of them happen at the same time. Okay, you cannot, this is life. You cannot, life is full of surprises. But there are some cases B will happen at the same time as A. Okay, we don't cannot, I mean, you cannot stop it, but B will happen at the same time as A. Previously, we said that B must happen after. That was a condition. Okay, for example, what that means that before you go to your car and drive your car, you need to have your keys in your hand first. Then you go to your car and drive it. If you don't have a keys, then you won't be able to start your car. That means you must have the key first, then you're able to drive your car. But in some kind of weird situation, you can either you can start. I mean, the key can happen first, then the call happen at the same time. I mean, it doesn't make any sense, but life is crazy. You're gonna see that things happen different part that you don't understand. Not all the times things are gonna happen the way you understand. So in the case in which B happen at the same time as A, we call them. We say that B and A are independent. Okay, so B and A are independent because B doesn't want A to happen. It just happened, just like A has happened, it happened with A. Okay, we expect B to happen after, but it happened with A. So in that case, you're gonna say B and A are called independent events. Okay, whenever they are independent events because they happen at the same time, this is what you do. You're gonna say P of A given B will be equal to P of A. Okay. Now our formula P of A and B become P of A times P of B. But based on the example I give you earlier, I know it's a little bit weird based on what we did because it's the next example that we have here is a little bit different. So this one is based on the following thing. So here I give you P of B given A there. That's a bit different, but I have this one to give P of A given B. So I'm going to create the example for that. In this case, it's going to be B, P of A and B is equal to, okay, this one will be P of B, okay, times P of A given B. I follow the same pattern so you can understand, so you don't get messed up. Because this one B, the one is on at the bottom. Now, because P of A and B, because we have independent events, therefore I'm going to have the following thing. I'm going to have P of A and B is equal to P of B times P of A. Okay? My pencil, where are you? Okay, that'll be P of A. Because P of A and B is equal to P of A given B is equal to P of A. Now, because multiplication are commutative, you're going to just make it nicer because you put A first, then you're going to say P of A times P of B. Okay? You understand? So, because you can just flip them, doesn't matter. Okay, so to make it nicer to remember, because you put A first and you put A first, B comes second and B comes second. Just a matter of time. Just like in the past, you do 2 times 3, I'll give you 6. And also the same thing, 3 times 2, still give you 6. Just because you change the order doesn't change it. This is called commutativity of the multiplication symbol. That's called commutativity. We can flip them. You want to make any difference, okay? So this is what it means. Just like I should tell you earlier, sometimes B doesn't want to happen after A, just happen with A, okay? So it's intuitively events are independent if knowledge of B does not change the probability of A occurring. In that case, knowing that B happened first, you will not affect A. It will happen no matter what, or as B is happening. All right. Does anybody have any question for me? Okay, so nobody say anything, so I assume that you guys understand. So here, there's an example here we have over here. Say two 6-sided dice are won. So you got 2 of them that are won. A will be the event that the dice sum to be 7, and B the event that the first die lands on a 4. So the first die lands on a 4. Want to know whether A and B are independent? Okay. So if we talk about dice before, okay, we talk about dice before. So I don't have to explain the picture again, so I can just show you this one first. So we got two dice in this case, okay? So you can have, whenever you have two dice, you can have whenever one is 6, etc. So now in this case, we want to worry about whether it's 7 and the other one is 4, okay? So again, let me remind you quickly, if for dice, for the first die, 2, 3, 4, 5, and 6. That's the first case, and then you got 1, 2, 3, 4, 5, and 6. So then you put them together. You got phases that are 1 and 1. If you put them on the floor, that 1 and 1, you got 1 and 2, 1 and 3, etc. But now we only worry about the fact whenever the sum add to 7 and the first, I mean, and be given that the first die lands on a 4. Okay, so let's see. So B is given the first die lands on a 4. So to have a 7, we have a total of 36. I don't know if you remember that. You have 36 even in total. Because if you do the table, it's 6 times to give you 36. So to get, so do P of A now. The sum is 7, P of A. Okay, out of 36, so let's see, you're gonna have 1 and 6 is 7, 2 and 5 is 7, 4 and 3 is 7, 4 and 3 is 7, right? So that's mean it happens like 1, 2, 3, 4, 5, 6 times. You're gonna be happen 6 times out of the 36 ways. 6 times out of 36 ways. That'll be 6, I'm sorry, 6 out of 36 options. Then you have to do that, man. But now they say this one say and the event that the first die lands on a 4. So so I can say about this one. So B is the event. You want to know whether A and B are independent. So first of all, let's try to get let me see. What we can do here is the following thing. Set B the event that the dice sum up to 7, and B the event that the first die lands on a 4. So if you look carefully, let's look at the first one, and then you're gonna see that carefully. You got 4, 1, etc. Go all the way here, and then 4, and then 6. Okay, you got 4, 5, etc. But there's a part you're gonna have 4 and 3 that added to give you 7. Okay, here the first die land on a 7. I mean the first die land on a 8. So that would be 6 cases also. Okay, so if you want to do P of B by itself, that'd be also 6 cases. Okay, you want to know whether they're independent. Let's find something here. So suppose I say, if you want to know whether they're independent, it means that if they're independent, that means the P of, oh, I don't want to write here. It means that P of A, okay, P of A given B must be equal to P of A if they are independent. And just in case they are independent, let's look carefully. P of A given B must equal to P of A if they are independent, right? That's what I said earlier. Let me just show you quickly earlier. See, P of A given B is equal to P of A. That means they are independent. Let's see we have that here. Notice that P of A is 6 out of 36. Now, what is P of A given B? What will it give me? So it's P of A given B. That's going to give you P of A and B over P of B. Okay, Let's see. P of A and B. What does this one give me? We did say that it happens 6 times out of 36. Okay, so let's see, that's going to give you 6 on top. It will be 6. I'm sorry, P of A and B. Hold on. I forgot to put something quickly. Let's just see where's that. This is what we have. So it's going to be something like this. To get P of B, B happens 6 times out of 36. Okay, and then P of A and B, that means the number is 7, and at the same time, the first number starts with a 4. Okay, the number is 7 starts with 4. That with this guy, it happened only 1 time out of 36. Okay. So if you do the math, that's going to give you the statistic go away. That's going to give you 1 out of 6. Okay, as you can see, P of A and B is equal to P of A. If you do that math here, if you simply, that'll be 1 out of 6. So if you do that math, therefore, the A and B are independent. That's what I can say. So let's do this one here. So P of A again is 6 out of 36. That's just going to give you, again, 1 out of 6. And then P of A and B just going to give you 1 out of 6, just how we do right here. Okay. Because they're the same, we have P of A and B is equal to P of A. I mean, P of A given B is equal to B. Therefore, we're going to say A and B are independent events. Okay. Any questions about those Chinese things I just explained? If it doesn't match, then it's not independent. Okay. If you don't have P of A given B is equal to P of A, first you find P of A, then you find P of B and compare them. If they're not the same, then they are not independent. If they are the same, then they are independent. Okay. So let me see if I can go to one more quickly example on that. And I'm gonna pull up the notes for you online. Let me see. Give me one moment. Okay, that's some other example. And let me get you show you an example here. I'm not gonna do it quickly with you. So here, and that case, 55% of all students at the university are females, and 30% are graduated 4 years, something like that. And then 13% of them are women who graduated in 4 years. So then same idea, F me female, mean graduate in 4 years. And then after that, probably to be a female and graduating is going to be, and graduate is going to be 0.13. Then probability of F and G and P of G, that'll be 0.16, 165. Then because they're not the same, they're going to say they're not independent. Okay. So why did they got the P of F again? So don't get confused. Here, what they do, and this one, and they were also at the university in 4 years. So here, why here they can say P of G given F. So you got it given that you're female because, so why want to know? We don't know whether this is equal to P of G. Okay. So that's another way to do it. Somebody can do that way too. That's another way to just a different pattern by doing the multiplication rule. But at the same time, I can see that carefully. You can also, this one equal to P of F, something like that. Okay. You can also do the same way. Here there is a multiplication rule that way. But not want to know that sometime it can happen they're not the same. Okay. If they're not the same, you're gonna say they are not independent. They are not independent. Okay. So that's an example. You can just, I'm just gonna let you guys read through it. Okay. And then I'm gonna have to stop here and I'll continue on Thursday. Let me see what I'm supposed to be in here. Yeah, I'm gonna stop here and finish and continue on Thursday. No, I have one more example to do. No, no. Yep. No. Yeah, I have one more example to do. I'm sorry. So it's 37. I have one more example to do. Let's see right here. Yeah. That's in that this time I'm gonna let you to go and read on them. So this one here. This is a woman called Sally. I'm gonna give me like 4 minutes to do it because it's 6:37. 4 minutes to do this one. Her name is Sally. She claimed that her 2 babies died of SIDS. Okay. Based on the statistics, only 1 in 8,540 babies died from SIDS. SIDS mean I think it's student infant death syndrome. Okay. So she claimed that her babies died from SIDS. 2 babies. She had 2 babies, both of them died from SIDS. Okay. But we know the rule say 1 out of 8,542 babies died from SIDS. Okay. So we want to know how likely is that the 2 baby will die of SIDS. How likely is up and down? How likely? That's the question behind that. Again, we're going to assume that the 2 events are independent. That means the first baby, probability for the first baby I'll call baby A, and baby B will die from SIDS. That'll be equal to, because it's independent, you're going to be probability of A times the probability of B. Where did I get that formula again? I'm going to show you where I got it. This is not new. Let me show you where I got that formula so you don't get confused. So we'll go all the way to here. Whenever I talk about independent, right here, this is why I talk about it. I say when something are independent, it means it's equivalent. P of A and B is equal to P of A times P of B. So that's what I talk about. P of A and B is equal to P of A times P of B. That's what I'm using right now. Okay, so that's been independent. So I'm going to go back to my example and try to explain the idea. So that means the first baby will die from SIDS. That'll be 1 out of 8,543. Time the second baby will die from SIDS will be also 1 out of 8,543. Then if you do the math, it gives you something like this. 1/72,982,849. So this case happened 1 out of 73 million for 2 babies to die from SIDS. Okay, I'm asking you this question based on this math question. Do you think it is likely to happen? Yes or no? Okay, somebody say no. Thank you very much. Can somebody give me, if you do 1 out of 70 million, that'll give you 0.0 something, some number, 00, right? And some number, right? That's number. And also, I think in the past, we talked about something called, let me go back quickly to the previous part of probabilities. Right here. No, not there. Yeah. So we say that when something is close to 0, like this, it's kind of impossible. If you round the thing to 0, it seems like it's kind of impossible. Okay, because this number is really close to 0. Or if it's really close to 0, it means that it's like what do you guys think? It says somebody will say it's gonna be unlikely to occur. Okay, so give me 1 moment, please. Okay, so let me see the example I was doing again. Where are we? We did this one. All right, here. So that's maybe 0.0 something. So I can, as you can see, because this is where, okay, it cannot happen by chance. So you cannot say that C is the cause of death because that's kind of impossible. Mathematically, it's impossible. So the events were not, we cannot say that, you can say that the events were not independent. Both kids could have died from C at the same time. That's impossible. Okay. So the thing will be that she's guilty. The math will prove that she's guilty. Right. So we do use math whenever we do this. I mean, basically, that's not basic sense. It means that that's impossible. There's no way two persons can die from that. You understand? So that means she killed, you mean the idea she killed both babies. All right. So what I'm gonna be doing, I'm gonna upload the notes for you to read. And then and I will continue on Thursday. All right. So have a good evening. And then if you have any questions for me, you're welcome to say so I can ask, I can help you out. Okay, so let me just stop the recording.